Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field.
Hey, have you ever been faced with the challenge of sourcing, installing, and programming a used control module in a vehicle? I know a lot of us have. It seems to be happening more and more often today with the volume of control modules on vehicles, the cost of some new ones, or even the availability of new control modules. In some cases, used may be the only option. So what do you do here? I strongly recommend checking out SJ Auto Solutions and Tommy Oliva. Tommy offers a cloning service for used control modules to make these things plug and play for the vehicle that you're working on. In a lot of cases, he is also able to source the control modules if you're unable to locate one for the vehicle that you're working on. But once you get connected with Tommy, he's going to offer fantastic support from start to finish to make sure that that control module is going to work in your application. He's also got tech support that he offers through his website, along with some free resources there as well on information about used control module programming. So make sure to check out SJ Auto Solutions. I can't recommend that enough. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. You got just me this week. I've got another case study for you here. This one's pretty interesting. Definitely something strange. I don't know if I'll see this one again. Maybe. Hard to say. Time may prove that this was a one-off or it's something that could happen more than once on these vehicles. But just for clarification, this was at a shop where a listener of the show works. And so I want to give this technician all the credit in the world. This was not a simple, straightforward problem by any means. And this guy is a sharp technician, a friend of mine. And I won't put his name on here. I don't know if he wants it or not. He can claim credit in the Facebook group if he wants to. Anyways, sometimes we come in and we're just like, oh man, you couldn't figure that out. And just in all honesty, that like sometimes it's like, oh, did you guys even really try? That was not this situation. This is a really strange one. So I'll get into it. It's a 2016 Kia Optima with a 2.4 liter. Okay. And the code that is setting in this is a P0010, which is simply just a circuit code for the ECVVT motor, which is basically just the electronic phaser for the intake camshaft. Now, you may hear that and you may work on these vehicles and you might be like, well, this is a really common problem with some really known solutions, right? You can hop on YouTube and punch in Kia 2.4 P0010 and you'll have 20 videos of people repairing this in various ways. But again, it is simply put in service information, or the definition of the code on your scan tool is, hey, there's a circuit problem with the control motor for this electronic phaser. Okay. Now this phaser again is going to use just power and ground to operate, but it operates much more different than your traditional VVT phaser. And to be totally honest, describing it over audio is not the best way to go on YouTube and watch some videos of these electronic phasers and how they work. It's kind of a dynamic component and it's interesting, but it's still an electrical motor. It's got power and ground. Okay. It's got actual contacts on it. It's got brushes, if you will. It's more like a brush style motor. And that can actually be a point of failure within these when you have your plug-in that goes onto the actual assembly. So think about the front of the engine. You got the front of the timing cover, you've got the sprocket, and you've got this electronic phaser. It's got an aluminum cap that kind of goes over the top of this thing. And then at the top of the aluminum cap, you have a plastic piece that has the connection for the electrical plug-in, but it's also got two brushes that protrude inside of the cap to make contact with this electrical motor. And on the front of the phaser and the motor, you have, basically just two copper rings that serve as the armature, if you will. Not exactly set up that way, but that's the idea there, is you're just trying to make electrical contact to this component, and as it spins, you can still apply power and ground to it to actuate it to move the camshaft, right? The end result is the same as everything we've been doing with variable valve timing, is to be able to move the camshaft back and forth, all right? Change the timing under different loads. That's nothing new. They're just approaching it a different way here. And these systems are highly problematic, as can be seen by all the YouTube videos. If you go on, you can watch them. And they have lots of different failure points, right? So the actual contacts themselves, the brushes and the contacts on the front, can become damaged. And you can actually see like chunks of the copper come off. And clearly that's going to cause a circuit problem. And it's also well known, and you remove this cap and you can see the carnage and, okay, hey, replace it. You can also have oil intrude into this cap. Now, of course, there's supposed to be oil behind the timing chain, but not within this assembly. This is electrical contacts, and it's not meant to be in an oil bath. But there's a plug in the center of this unit that can either come out or leak, and there's a whole TSB about it if you look this up, and it's a known problem, okay? Of course, you can have other problems like wiring or an ECM failure, or maybe an internal failure of the solenoid. Any of that could happen. Maybe the contacts on the connector, any of that. But here's the deal. This shop, again, being a Sharp technician, and they have some pretty good resources of their own, they've replaced all of that and still had this P0010 setting on this vehicle. So, okay. And here's everything that's been replaced. And not willy-nilly, like, let's just throw everything at this car. It's, hey, we replaced this, we still have this code. Okay, well, let's go to the next component. And they actually did find things that were failed along the way. They found a problem with the plug. They found actual damaged contacts. And they even found that there was no control coming out of the PCM for this circuit. Like, they have a picoscope, and they were looking at how it was outputting and the fact that it wasn't. And this was our first involvement with the car, actually, was when they called us and they say, hey, we'd like to do a used engine control module on this 16 Kia. Can you do that for us? And we can. And we cloned it. My guy Keegan cloned it. He's getting really good at that stuff, so shout out to him. But that was our first call onto this car, is, can you clone this module? So we did, cloned it over, got it to him, and I didn't hear anything about it immediately after until this week when they called us and said, like, hey, we've been through just about everything on this car, and, we're still getting this code. And, we've gone back in, and they have some internal resources which directed them towards, maybe this code doesn't actually mean circuit code. Maybe it's referencing timing. Maybe it's something more dynamic than what you're understanding, meaning that maybe there's a double meaning to the code, or some performance aspect of the motor or the cam phasing or not phasing will set this code. And so they went in and they checked timing on this thing a couple times, actually. I talked to the tech that did it. He wasn't in the greatest mood about having to tear this motor apart multiple times just to say that, yep, the timing is still on. And it was. So anyways, get into this vehicle. And I do have the advantage here of starting fresh with this, of just like, I'm just going to take it at face value, what it is. I'm not going to consider any of the parts that had been replaced. I mean, I am, but I'm not going to walk into it thinking that all of these parts are good. Obviously, something's a problem. I'm just going to take it fresh like it would a normal problem and let my tests guide me to what needs to be replaced. This episode is brought to you by autorescuetools.com and Isaac Rodell. If you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's autorescuetools.com. The link will be in the show notes. Rather than, and I do this myself too, I already put that part on there. It's not the problem. And, all of us that do this, we can get into that, and that can be, a hang up or waste a lot of time. So anyways, I'm going to come into it fresh, and I do find that this code is present and it is consistent, which is nice. It's not an intermittent thing. And the one thing that I find with this code is that I found was interesting and actually led me to being able to solve this in the end was that this code would not set when the vehicle was running, at least not the amount of running that I did with it, but I don't believe it would have. And this took me a little bit to figure out, but I found that this code would only set after a key cycle, meaning that you could run this thing for a period of time and, up and down with the RPM, make sure that the phaser is actually operating. And I actually did put a scope, not only looking at amperage, but both control sides of the motor. It's a 2-wire motor, but it will move it in different directions. So you can see the amperage go in different directions. And obviously it's a H-bridge style circuit, kind of like a electric throttle motor where it can have ground on one side, power on the other, and then flip-flop them to move it the opposite direction. Anyways, I'm looking at that. So I have 3 channels on this, and it's operating, and the current looks good, and it's moving up and down, not setting this code at all. It was there when I got there, running it, doesn't set it. But with a key cycle, this code sets. As soon as you start it back up, it's got the 0010, and you can clear it out, and it will not set again until you do a key cycle. So I tried something here. I was like, okay, the key cycle definitely has something to do with it. I don't know what that logic is exactly, but there's something there. So I tried just turning the key off and then turning the key back on, and I get this code. And the reason I'm trying that is because this is a circuit code, right? This is by definition, and what Kia's description of this code is, an open circuit to the intake control motor. Not a timing code, not a performance, not a delayed operation, a circuit code. So I was like, okay, well, if it's all it needs is a key cycle, number one, that makes it easier to, actually duplicate and to test. But yeah, I don't have to run the motor. I don't have to go drive it. And it proves out to me pretty clearly that this is definitely a circuit code. There's nothing else that it's looking at for performance or operation or whatever else. It's circuit. We got to look at this electrically. And that seems to be the case. Okay, so cycle of that key and it sets the code. You don't even have to start the engine up. Get that 0010 every single time. Now, if you don't cycle the key, you don't get the code. If you run the engine, you don't get the code. And I'm looking at the scope and I see the amperage going both directions. I see the control on both sides and flip-flop depending on which way it wants it to go. And all of that looks good to me. Now, do I know perfectly exactly what it should look like? No, not necessarily, but it looks like the motor is moving, and it would appear that the computer's happy with it while the engine's running, or at least while I just hold the key in the on position. But especially while it's operating, it looks pretty good. And it seems to be happy with it, and it's operating the circuit. It's definitely not an open circuit. Like, this thing is actually operating, and it's all new parts, so it should be operating. But something with the key cycle is what's triggering it, and that's what I've got to figure out. So I did look a little closer at the code enable criteria, and what actually sets this code. And sometimes there are codes like this where there's more to it than just the definition of the code. And you got to dig deeper into service information. And hopefully the manufacturer provided you with something that explains what it's actually looking for, what's making the module happy or unhappy. And we all know there's lots of applications and scenarios and codes and modules and circuits where they don't share that with you. It's a really vague reason why code's set. It'll be like, the measured value differs from calculated values or predetermined values, but it doesn't tell you what those are. And a gazillion examples of that. But sometimes they do provide you with helpful information that you can use to try to figure out what's going on. And I won't say that this led me exactly to where I needed to go, but it got me thinking about it at least. And so here's the deal. When you go into the code and you look at the DTC detecting condition, and this is right off of all data, you can probably get it through Identifix or whatever service information you're using. So this isn't anything special. Just search the code in there. There's two cases that are under DTC strategy. Okay. And it says both of them, they're electrical checks. Okay. So case one, I'm not going to read it verbatim, but essentially what it's saying is, after a certain pulse width modulation to the motor, it expects a certain amperage amount on the circuit. Okay, so we commanded the circuit on, there should be a certain amount of current. Makes sense, right? If there's not, it determines that to be an open circuit. Cool. Case two, it is looking at the circuit when it is not commanding the motor. And it doesn't give you any specifics right here, but it's saying that it's looking at the circuit when the motor is off. And again, not really anything beyond that. And actually, it's sort of vague in its definition here. It says the power stage of the ECVVT motor is off. And then it's saying that the voltage after the ECVVT relay is between 10 and 16 volts. Power stage off delay time plus system delay time longer than 0.2 seconds. So to be totally honest, I read that. I'm like, I'm not really sure what that means, except for it seems like it's looking at something when the motor is off. And by motor, I mean the electric motor, the actual actuator. It's looking at it. Now that could be when the engine is off. Maybe it's while the engine's running, but at the very least, I get that it's looking at this circuit in two different states. When it's operating, I'm looking for current. When it's off, I'm looking for something, but it doesn't define exactly what that is. Now, if you go to the component inspection part of the DTC. And if you look up this code within all data, it'll have different sections. And one of them is component inspection. And the component inspection has you actually do some circuit checks for this code. And it provided some useful information. And I think this will be useful for you if you look at these. You can also find this on Identifix too, broken down into more of like a real world test. But they have it in service information, but you've got to pay attention and actually go through the steps to find it. But essentially what it's saying in service info is if you look at either the positive or the negative side of this motor, and I realize they can be flip-flopped, but if you look at the positive and the negative side, the two wires that go to this, they should each read 3.6 volts when the motor is not being operated. Now, if it is being operated, you'll see the voltage move, and they actually have a waveform of that. Now, if you unplug this, and this is something that they don't include in service information, but it is in Identifix, you'll see 11 volts on one side, on the positive side, and you'll see 0.5 volts on the negative side. Okay, so what does all this mean here? And this took me a little while to figure out, but essentially what this is, well, when the motor is being operated, you're going to see voltage, being applied to either side. You're going to see amperage going through it, right? It's a, 2-wire power ground circuit. That's pretty straightforward. And it's got a pulse width modulated driver to do it. So look for that when it's operating. And I did. It looks great. But when it's off, meaning when it does not want to command that motor to move at all, there will still be a voltage. There will be 11 volts on the positive side and 0.5 on the other with it disconnected. Plugged in, you have 3.6 on both sides, approximately, pretty close to that. And says you should expect that in the service information. What does that mean? That means that this has a bias voltage that comes out of the ECM, goes through the motor, drops across the motor, comes back to the ECM, and it is expecting a certain amount of drop, and it's expecting 3.6 volts on both sides. Now, is it monitoring both sides? For sure, I don't know. Probably, it's hard to say, but it is monitoring that circuit, and that's case 2. That's we are not actuating this motor, but we're using a bias voltage to make sure that it is still intact electrically. Okay, so there's our 2 cases. We look at amperage when we're operating. If it's not there above a certain pulse width modulation, we said, hey, there's an open circuit. And we look at the circuit when it's off with a bias voltage, looking for voltage drop. If that's not where we expect it to be, we set a circuit code. So that's pretty straightforward, okay? Now, what do I have on this car? Plugged in, I have 3.6 volts on both sides. Unplugged, I have 11 and 0.5. Operating, I have amperage. Now, is it the exact amperage? I don't know, but it doesn't set running. So I didn't dig too deep into that. And the motor seems to be moving, seems to be functioning. Okay, now, where do I go with this? And they had all been through this too. He had looked at all of this. He had gone through this, and they were struggling with it. Okay, so looking at the circuit, and you can see this on the diagrams. It's not only a power feed and ground feed to the motor itself. There is also a relay that provides power to the ECM for this circuit to work. And you see this with a lot of like high current devices that get run by an engine control module or module of any type, where they'll have their own dedicated power feed with a dedicated relay that provides power to them. And this is one of them. So there's an ECVVT relay, which the ECM commands, but it sends power to the engine control module, and then through a rail on the inside of that module, it then applies that power to the motor using some drivers, depending on the direction it wants it to go. Okay, so I said, well, I'm going to check and see what this relay is doing. Now, why am I going this direction? Well, I've assessed the circuit. They've assessed the circuit. It looks okay. I don't see any problem with it. So what else do we have left here of this system that we could check? Well, there is this relay that feeds power in. And my first thought was, maybe this relay is not feeding the correct amount of power to this. Maybe maybe there's a voltage drop was what I was kind of thinking. And I was like, well, I'm just going to check it and see what happens. But I'm also interested to see what happens during the key cycle. Now, I was looking at the output side, and that 3.6 volts drops to 0 approximately 5 seconds after you shut the key off, turns back on when you turn the key on, okay? But I want to see what happens on this input side from the relay. And this is where it actually got me somewhere that I needed to go. So scoping that side, when I shut the key off, I can see the voltage drop off on the output side, but it does not drop, at least not totally on the relay side. It drops a little bit below, like, because sitting at battery voltage when your key is on, and it would drop below and it would very slowly slope down. And so there's still voltage on that input side. And as soon as I saw that, I'm like, okay, I am onto something here. And I was thinking it was probably just a relay sticking, okay? Because if you'd wait long enough, it would eventually trail down, but it was a period of minutes. And that's not how relays work. It should be off pretty quickly. So I'm like, oh, okay, well, this is just a relay. So I unplugged the relay and still have power. Well, I should say, if I put it into that state, right, where I shut it off and I'm waiting for that voltage to trail down. If I yank the relay out at that point, I still have power there. And there's also 2 fuses that go to it between the relay and the ECM. Pulled those, still have power. I unplug the ECM and I lose power there. Okay. Now the question is, okay, it's seems to be coming out of the ECM, but is there another circuit that is feeding into that ECM? And I actually spent a bit of time here trying to figure that out of, okay, is there any other, power feed that's staying on a different circuit that's affecting this circuit? I couldn't find it with the checks that I was doing. I was able to eliminate, so there's 2 connectors on the ECM, and I unplugged one, and I still had the same symptoms. I'm like, well, it can't be any of those circuits. But as it turned out, it wasn't any of the circuits. And I did begin questioning him a little bit more on the details of his tests for, each different scenario. And I was curious to know, like, was this the problem with the old one exactly, like the way we're seeing it? And I was kind of thinking maybe I cloned over a problem. I've done that before. That's happened. This is a weird one. Circuit problems generally don't get cloned over, but hey, anything's possible. But when I was talking to him, he said, well, the original ECM had no control over the motor, which is why we replaced it. We didn't just chuck it at it willy-nilly. Like, it had no output at all to the actual intake actuator. I was like, well, that's kind of strange. So luckily, they had the original one there. I'm like, well, let's plug this one in. I should have thought of that sooner. I didn't, but that's the way it goes. But I was like, let's plug this one in and see, do we have the same situation or not? And guess what? We didn't. That power that's looked like it was coming from the relay dropped off after the 5 seconds. But that ECM had no control over the motor. Whatever driver circuit was in there was dead. And so they correctly replaced that. But the ECM they got had a different problem. This one had power that was backfeeding onto the input side after the key had been shut off. Now, why this was occurring, I don't know. These circuits appear to be sensitive to these intake actuators. And I can say I ohm checked, it was pretty low resistance. Now running, maybe that changes a little bit, but they're pulling some good amperage out of these. And of course, a driver circuit for something that's pulling a lot of amperage is going to be susceptible to damage. And that seems to be the case here. Now, like, almost every part of this system seems to be susceptible to failure, but the ECM included in that. But we had one where the driver was completely burnt out, not actuating at all. And then we had one that, although it was actuating that motor, it was backfeeding voltage onto the input side. Okay, so 2 different problems, 2 different ECMs. Now, why was it setting an open circuit code with this happening? And that one's a little tougher to find, but my guess is because there was still power on the input side, like it would appear to be coming from that relay, especially to the module, that it continued its logic of looking at the output side even after it dropped to 0, right? Because after 5 seconds, that voltage going to the actual intake control motor would drop to 0, as it's supposed to, but it was still having voltage on the relay input. And my guess is it's a comparative value, and it was still looking to see that 3.6. It didn't, so it flags the code, and that's why you needed the key cycle for it to happen. I can't say that with 100% confidence, but that's my best understanding of what's going on there and how it interpreted a shorted power feed on the input side as an open circuit on the output side. It's just that it's programmed to look at that voltage and it wants to see 3.6 as long as it's being fed power into the module. Again, my best guess there, but it makes sense with what we saw. So they get a brand new ECM from Kia, which, by the way, was not an easy thing to do. They would have done that in the first place, but they were in back order, and there just happened to be one that somebody ordered and then didn't end up buying, and so they were able to get that. We put that in there, we programmed it up, and all good, no problems. System works great. So that was it. Anyways, I hope you found that interesting. I hope that transferred well audio only. I haven't done a real technical electrical explanation recently, so you'll have to let me know if that transfers well enough in your mind. But you know what? Like, it's good to really push your understanding of things like electrical circuits. Like, can you envision it without a diagram? If you can, you're probably in like the upper echelon of diagnostic technicians. And I'm serious about that. Like, having a good mental model about this stuff, I think is really important. So if you can listen to that and you can picture, oh yeah, okay, 3.6 volts and 12 volts, that's awesome. But maybe you're like, Sean, this doesn't make sense on a podcast. Like, let me know. Honestly, I could put some more effort into videos. I haven't done that. But anyways, that's where I'm wrapping this one up. I've been talking long enough. Thank you so much for listening. Always appreciate it. With that out of the way, let's get out there, start fixing the world one car at a time.